I'll introduce myself. I work for Netcam. I used to study yacht carpentry and yacht manufacturing in Southampton. Did that for mainly over the years. I've mainly worked on boat building, but also in other trades, partly for car manufacturers or aerospace, etc. I'll show some examples that we are working in these businesses as well. There we go. So it's Netcam for me now since over a year. In the marine industry, we tend to concentrate on like a full tooling solution. So we take our customers from a very early rendered model on 3D, where we make it into a plug, like a full one-to-one scale. From that we'll take a mold, and we can provide you with that information on how to actually build your product inside that mold. That way we mainly concentrated on marine business. Some of the examples of projects which we've been on in the cradle of, we've rocked their cradles in the very beginning, having the honor to produce the first models was, for example, Van Dutch, which was a great project several years ago. Recently, the G4 built by Holland Composites, where we were allowed to do the models in this case. And now, as you might have seen on our booth, we're using the example of the Zeelander 55, showing that that these sort of development strategy processes can be very, very efficient. Within due time, you will see the Elling 5 coming up to the market, which will be somewhere early next year. Production development is well underway. As I indicated, we're in the architecture business, automotive and aerospace, where in this case, to give you a bit of a glimpse on what we do apart from boat building and production developments in boat building, is, for example, concrete casting molds for, in this case, a bridge. And that's one of the issues. It's EPS with a hot spray coating. This is the City Council office in Utrecht, where they had a full composite facade, which was actually a closed molded technique, which enabled the builder here, once it was fixed to the building, that in and outside were finished with that much insulation. So and the building is a lot lighter as well. Models for Donkervoort, a local car producer, semi-custom car producer, and also booths on trade shows. In this case, it's where we could use our EPS and epoxy paste system to create that booth. Normally we'd use that as a model, but in this case it was a finished product. Then over the years, we had quite a lot of customers in art and art expressions, and in this case, it's a LED interior petal, as we call it. We did this in cooperation with Maramoya, where these were hung in the Louvre in Paris for an exhibition of a jewelry brand. And this one. Perhaps some of you might know it from the TV program The Voice. There's many producers who've been working on these models, but some of these hands came from our machines. Doing these kind of things, you can only do that by, first of all, having very good people, having very good craftsmanship who have the knowledge to work these things. However, they need their tools and they need their materials. We have a series of 5-axis tooling machines to our availability. The longest being 20 meters in length, and two 10 meters and a 6 meter, especially for aluminium and steel. Besides that, we have hot wire cutting machines to cut EPS into the required shape, and the various systems to finish it with paste or with hot spray or acrylic one. You need these tools to be able to be so flexible and serve that many different markets. It starts with basic materials like wood and bond it together and start shaping it into in this case art expressions. Then EPS and hot spray finish with in this case a fire retardant coating. This was a gas station along the road to Paris in Belgium, and that was we actually have a spin-off of our company about a year ago, where which now only concentrates on recreational and renovation markets. So that bigger market, it actually is. Architecture becomes more and more interesting to us. Then the smaller, in this case it was a scale model. When you have smaller lasting demands on these models, then you use a block material like a Sika block, like a polyurethane block material of a higher density, which will last you a bit longer. It's easier to finish. And then of course the larger, slightly complex models, that's where there's a requirement of EPS, and the EPS is then covered with sometimes covered with a laminate and finished with an epoxy paste, which is milled to perfection, in order to create these sort of models. And as I said, also for the smaller parts, also the refurbishing of these aluminium molds. We use those for and produce those also for RTM, so closed molded technique, allowing us in these different worlds, to adapt techniques and tricks from the one industry and introducing them into another industry, just to purely make each other's processes more efficient. Here, when it's a boat production mold, that's when we often work with the guys from Adel, who take our models and actually create the production molds from it. And then we do our complex infusions inside those molds. That's where we cooperate as well. We calculate our flow simulation and make sure that at the very first shot we get a successful infusion. And it's a way to assure to your customers where and how you have to go about this. Then for high temperature molding, there's some of the projects. There's more and more demand coming for high quality moldings fit for pre-pregs, carbon production, and then for the lower quantities, there's customers who require a direct tool. They're not looking to build many others and just need the basic shape to create their hull out of composites. Then aluminium molds and RTM molds, which we can do on our machines as well, like I mentioned before. Moving on to steel molds, and this is also one of the first pictures, and also the second bridges me to the second part of this presentation, where I will focus on the production process of one item, quite a large item, which you will see in a bit. I will tell you a story about the Neva Giant, the world's largest resin infusion for a minesweeper vessel for the Russian Navy, which was carried out in the in St. Petersburg in Russia. We were, I was involved when I was working for Polyworks, owned by Arjen Korva. I owe this whole project to him since I was working for him at the time. It was one mold, a big steel mold, 21 tons of resin. It was 45 tons of fabric, 1.5 kilometers of spiral tube, one vacuum bag in a single product, just a few shots. It's classed to be Project 12-700. The builder is Sretnevsky Shipyard, which is in St. Petersburg on the banks of the river Neva, as so called. It's a 62-meter single skin hull being produced, which we produce there, from e-glass and fire retardant vinyl ester, which is a requirement for these vessels. So, Composite Group Russia contacted us, being a market leader on flow development and 3D on-screen development and risk analysis for these kind of high-risk infusions, and where there's lots of material involved. It's actually it was 8 meters high, so we had some problems to overcome. You can't just simply kick this off. So we had this problem with the height. When you're doing an infusion, every 1 meter in height will actually push you. Gravity will stop you from going upwards. So basically, it will be limited up to 3.5 meters. You can't get any higher, and therefore we sold the project. So yes, we can do this. So we had to come up with a solution for that. So therefore, we had to do it in 2 infusions. I'll get into a bit more detail in a later stage. When I got the first model, it was just the model of the hull mold itself. A huge steel mold, which was built up out of 20 different sections, all separate sections along the keel line, and many sections along the sides, which could be moved out once the boat was finished, and then it could then be wheeled into the water on the slide. So it was then it was really pushing the boundaries on terms of size. But still, we had to overcome that problem with these heights, and so we set about on doing a 2-stage infusion. So it was still a single stack of dry glass material running up these big steel walls of 8 meters high, and one bag going from bottom to top, completing the full hull shape. But what we had to do is we had to stop the first infusion at a certain height, and then from there let it cure under vacuum, and then wait until the next day to continue with the next infusion. But we had to get the new feed lines already into position before the bag goes on. So I went about, and the guys from Brands MC Technics now offered us their lab, and together with these guys we just took a glass table, put it on its side, and infused the first part and the second part, and it worked. Yes. It worked with VAP membrane on one side, taking like Gore-Tex, taking all the air out, but the fluids stay inside. It's exactly what it does for in your jacket as well. So that worked, and I took my laptop and the flow program, went to Russia to do it again and show them, like, guys, this is possible. We can do this. This we can do. I'll show you here in the concept, and we're gonna now go on and work out into a bit more detail. So far, so good. That worked out. For the rest, there was much more to do. There was stirring quantities. For example, how do you mix degas? How do you feed that much resin into an infusion. Yeah, you can't just pour it into buckets, stir it, and let it go into your infusion. Simply wasn't gonna work for us, because you're gonna have to monitor these risks. So what we also the hose lengths. Your machines, the pots were on such a distance to the actual part that only the length of hose had its own restrictions. So that we had to make sure there was no human error in this system. If somebody just puts the wrong mix in, that we just simply couldn't work with that. So we said, okay, we're going to have to get a company on board who can do a mix and degas system for us, which mixes and organizes. But then I started looking around. There was no such system available anywhere. So I started talking and calling to a couple of these companies, and eventually setting out quite a few inquiries. There was only one 2KM in Germany who said, okay, we are happy to take this challenge, and we will develop you a machine which can give you those quantities. And so they did. It took a while, and then finally they delivered 2 fully automated machines, in which we worked in close cooperation to develop them, and they had pressure sensors in the manifolds inside the hull, which were spreading out all the resin to the feed points on the bag, and they had a whopping 60 kilograms a minute capacity each. So we could feed with 120 kilograms a minute. Another issue we had to overcome. Like I said, this mold was built up from many different little pieces. But in between these sections of mold, there's about a finger thick of nothing. So how are you ever going to pull a vacuum on there? So several systems passed our thoughts, but eventually relatively simple with some Sika, with some tape over the top. And once you've got the tape over the top, the vacuum will actually push the tape down and seal itself. Then another little issue, which many things become a huge job. And what's the release that you're going to use? This is not the kind of product you want to have stuck into your mold. And therefore, I made a full study about all the the release systems which could be used best in this particular mold type. And it was steel, and with the temperatures, what would work best. A full report about it. And then when I arrived, they had actually just painted the hull mold with a mixture of paraffin and diesel, and said, "Nah, that's going to work fine. We do it on all our molds as well. Don't you worry at all." It did come out very good. It actually pre-released. So we set out to do a U-shaped test. So just a section of that full ship to test our system, where we have, you see it, you can see it at the bottom. There's this lower, there's like the bottom area is infused in several sections, and there's the vertical branches on the side to about the maximum height where you can get with a one-shot infusion. And then after that, we'll wait for a day and we'll continue with the next bit. And theoretically, you could just continue even further. But we pulled it off. It was a successful first section. And of course, you can see that transition, but that wasn't an issue. They did many structural tests on that, but because we used the Gore-Tex or the VAP membrane, it made sure that the quality of that transition area was, it passed all the tests necessary. Then, of course, you got to be absolutely sure it works, because if this is going wrong, you need a very, very large dustbin. So, it's such a necessity that we set up a huge list of all the particular risks which we might find during such an infusion. And then, what if it's happening? What should people do? Because so we had to train the whole group of people inside that mold who were there to act and what to do when there was a leak or when there was a tube clogged or when, in that case, so that we set up an analysis for that and trained these people to be able to act if needed. And then everything, what normally on a boat or a hull or a deck is relatively small, but of course pulling a drop test on say just making a bag, for example, because it's that's all big jobs all of a sudden. You can't just check a resin system and hopefully it's going to be fine and wait for the technical data sheet. So it was continuous testing to make sure all our parameters were correct. And then, for example, 20 millimeters feed spiral, which you can get it up to 10 millimeters and this tubing, but you can't get it much bigger. So we had to sort of custom make it to get this done. Then this dry stack, because I said it's a single skin hull, and we had to, as you're on a horizontal surface, you can lay up your fibers pretty nicely, but once it goes up those big walls, that's where it's kind of tough to hang it up there. So you had to eventually just after every layer we had to clamp it at the very top with these steel plates, and then because it was 40 kilograms a square meter in weight, over 8 meters in height, pulling it down. So a bit of spray glue wasn't going to happen and wasn't going to work for us. So another thing to tackle, but eventually the clamping worked just fine. These clamps stayed underneath the bag, so we could leave them there during the infusion, making sure that the whole pack was staying up there. And so that succeeded eventually. Then a vacuum bag of 85 meters by 35 meters. We thought, okay, how are we going to make an efficient, big, huge bag like that? But eventually it was just start at the start and work your way towards the end by just patching and adding bits and bits and bits. But also that is, you have a separate room where there's people cutting the bags. There's another department where there's people just doing techie tapes, and everybody with cotton gloves to make sure these bags were not harmed. Because once you've got the whole job done and filled with bag, if there's a leak, try to find it. It's like finding a needle in a giant haystack. So also trying to get in between all that scaffolding. So therefore it's this suddenly becomes a challenge, just applying a bag. But the U-shaped section provided us with all the necessary information to pull off that resin infusion with in 2 stages for the full hull. And it was actually, so we finished off our entire strategy, some final testing, and in 2011 it was when at the first stage we infused over a time span of 3 hours, we infused 15 tons of resin and let that cure under the bag, whilst our new feeding tubes were already in position for the next day. And then the next day was over a time span of 2.5 hours, because it was slightly less height. We infused a 6 ton to fill up all the top sides. So in fact it was 2 shots, but still one continuous product. The first boat was launched in June 2014, and it's now serving the Russian Navy. And it's the second hull. I got some information. They infused it early this year, and here you see the first one embarking on its first voyage. All in all, I'm glad to be able to share this with you. So a few years later, and I hope you've enjoyed this telling. If you're interested, please visit us at the booth here around the corners, CMP 60. And thank you very much for your attention.